But sometimes you'll notice those funny shapes, it's easier to do right minus left. So I want to give you one of those. If you got your problem set, just look at number 6. I want to give you something like that. So that's what we're going to, for the rest of class, we're going to kind of hit on this kind of scenario. Which way should I do it? And we're going to make a choice. You know, sometimes it's easier dx dy, sometimes it's either dy dx, or sometimes it's easier either way. It doesn't make a big difference. And you can never split these up, right? I have to do everything iterated in these circuits. So I'm going to do one like that. Here's your bounded region. Oh, this is like number 6. So how about this? Can you do the integral of y? This is d. It says dA. So they're giving you an option. dx dy or dy dx. D is bounded by x equals y squared. And I'm going to change it up. How about x equal to 18 minus 1? I think the problem's had an 8. Be careful with that drawing. Be careful with the drawing. This guy, I just recently gave a test in Calc 2, and the drawing got people when they draw these. Those aren't functions, are they? But they're curves, right? What's this curve look like? It looks like this, right? One of these dudes. Well, then what's 18 minus y squared? Because it's negative? That's going to make it go up the 18 notches and shift this way, right? But it's the entire parabola. So what would this look like? Where is x equal to y squared? But this guy went what? 18 notches this way, and then opened up what? This way. Extend that x-axis. And I want you to make a decision on this. That's why our sketch was so important. These are going to meet somewhere. I have no idea where they're meeting. You're going to help me out with that. But then we got to make a choice of dx dy or dy dx. It's not a perfect drawing, but it's good enough. X-axis, y-axis. This side is the what? X equals 18 minus y squared. This side was the x equals y squared. And we had to come up with the double integral of y over that region D. This is D right here. The big error made by my Calc 2 students, I was saying, was they only thought to do first quadrant. It's like, no, the whole region D, bounded by those two curves. So what do you think is going to be easier? dx dy or dy dx? dx dy should be easier. You go, why? If we do dy dx, I want you to study it carefully. From here to here, who's the top and bottom? That's the top, that's the bottom. What happens when you get past here? The top and bottom change, bless you. So you would have to set up 2 separate double integrals and add them together. But if you're looking at it this way, okay, turn your head or turn the view. If you're looking at it this way, who's the entire top? That dude. And who's the entire bottom over that region? This one, I have to do one integral. So I really highly recommend with this problem, let's do dx dy. I'm like, okay, I'm going to do dx dy. This just stays y. And I'm stuck. I need numbers. These have to be y values. I have no idea what they are. So what's the math method where you find where two curves intersect each other?
You set them equal.
Set them equal to each other. Let's do that. So I'm going to do some algebra and see what's my limits. If I can fix this. What does 18 minus y squared equal y squared? Okay, where does 18 equal 2y squared? Okay, where does 9 equal y squared? What two values?
Plus minus 3.
You got it. Now, if you want to make your picture a little better, that's a -3. That's a +3. And not stuck anymore. These are my y values. Now, I want to make sure you get these limits right. Which equation goes there? And which equation goes here? Remember right minus left? So you get the net cramp? Which one's on the right?
18 minus y square.
There you go, and the bottom left. Right? Left. Right? Left. Guess what would happen if I had to switch it around? You would get negative what the actual answer is. Right? Hey, some answers can be negative though. I want to point that out. Don't freak out. You can get negative answers for double integrals. Just like you got negative answers for single integrals. It's like a net volume or net area. Like we did in Calc 1, net volume. Or you could get a 0. But when I can't split this up, so I was wondering if you could work this with me. Because I have no idea what this is going to come out to be. I was looking at this going, alright, what are we going to do? What's the number of y respect to x?
Yx.
Okay, x, y. Now what do I got to substitute into the x?
18y minus y square.
I'm going to plug that into x, then plug this into x, right? And keep that little y next to it. So I get 18 minus y squared times that y, subtract y squared times y. Which is now what? And I'll carry this down. What is all that? 18y minus y cubed
Minus y cube.
minus y cubed. Or 18y minus 1.
2y cube.
And what's my limits? I carry down. Now I know this answer. And I bet you some people in this class know this answer without even doing the math. Do you recall odd functions? See, we got it down to a single integral. And I notice that's an odd expression. See the odd powers? And I know something funny happens on integrals when you do a negative to a positive of the same value over an odd region. I'll give you an example like x cubed. Like x cubed is odd, right? They call it an odd function. What happens when you go from like there to there to a single integral? Guess what you get? I bet you we get 0. Well, let's see. Let's play it out. 18y squared over 2 minus 2y to the fourth over 4, but I think we're going to get 0, aren't we? Because we got it down to that center integral. And let's see what we get. 9 times 3 is squared is 81 minus 81 over 2 minus, yep, 81. Just like we thought. What do you get? Let's see it. Let's see it. 0. We evaluated that out. So what's that saying? This is a plane. That's not a like in, you know, one of those like paraboloids or anything. Paraboloid here would be like x squared plus y squared. What would a sphere be here? Right? Oh, x squared plus y squared plus z. You go, wait a minute. So it's got that z squared, right? They'd have to solve, like, do a hemisphere. That's how you'd have to treat the problem. And I bet you some of you know how to deal with that. You got x squared plus y squared plus z squared equals 4. You can solve for the z. Well, what's going on here with this plane? It looks like over that region, half the plane was what? Half the, you know, over that region, plane was above for half the region, then the other half of the region, it was what? Below the xy plane. That's exactly what's happening. We could look at that with software. That's what you'd see. You'd see it like kind of slice right through the middle of this. Right? Maybe it came down this way and it's giving that double integral to come out to be a 0, answer is 0. Hey, cool. Okay, let's look at another one where you get to make the decision. You get to make the choice. Do I have it like this on the practice set? If not, I can tell you where I get it from the textbook. No. Well, boy, I'm upset. I thought that these would be more like this somewhere. Oh, nah. Anyways, Owen, I'm going to take this from section 15.3, but this is like number 22. But this is like number 19. So these are the problems I'm taking. It's in 15.3, but it's something like 19, it's something like number 22. They give you a setup, they care about D, and you're going to make the decision how you want to set it up. And heck, maybe either way is fine. So what you got to do, and when you estimate, or excuse me, evaluate, estimate would be a Riemann sum. Evaluate. Double integral, X. Oh, and they put dA here. And then they put a D down here for that region of integration. Where D is the triangular region. With vertices, 0, 0, 2, 2, and 4, 0. Oh, hang on, 0, 4. This is like number 19 and 22 of the textbook. You can estimate this. Because again, we're estimating net volume, right? Let's make that picture, and then we're all going to make a decision on how to handle this. So draw that. 0, 0. I think the hardest part is plotting these correctly. Where's 2, 2? Well, that is that point. Where is that? Over here, over here. That's maybe the biggest. That's where the biggest error can occur during a test. We accidentally plot the point in the wrong spot because they made us plot the points. Where is 0, 4? That's over on the y-axis. Don't we agree?
Mm-hmm.
There you go. Shade it in. The triangle. And a triangle is a general region. So I might as well add it to this image. Triangles are general regions. That means you can't split it up. What you're going to have to do is an iterated integral. The only time I can split it up is if it's a rectangle and everything can be written as a product of x and y's.
Could you do this as the full rectangle and divide by 2?
Great question. If you had knowledge of this surface being consistent over that, like a flat roof, that would work. So that's the thing, we're in Calc 3 now, everyone. And I love the way you think. Like, let's take the quick way to a solution. But now we got a surface involved, like a rooftop. And if it's fully flat, that works. But if it's what? Slanted one way or the other, then we can't do that. So I'm going to treat it as we have, I know it says z equals x there, but we're going to have to do this whole problem because we can't assume that's going to be consistent over the whole thing in terms of taking a rectangle and divide by 2. Great question. You want to do dy dx, dx dy? Here's my decision. I'm going to do dy dx. The reason? From here to here, who's the top, who's the bottom? Look at it. Who's the top was always this, the bottom was that, right? If you do dx dy, turn your head or turn your piece of paper. Doesn't it switch? So if you do dx dy, you're going to need 2 double integrals set up. You're going to have to sum the 2. You're going to have to do one from there to there, top over bottom. Then add it to here, top over bottom. Do you follow me? So when I'm making my decision here, I'm definitely doing dy dx because I don't want to do 2 double integrals. I just want to do what? 1. So I'm going, all right, there I go. Double integral, dy, the dx, this is just an x. Now let's start with the easy stuff. These have to be numbers. They have to be values. So what's the outer limit for x?
0 and 2.
0 to 2. Very good, see? Those have to be numbers, always, 2 numbers. But these, it looks like we got equations and I'm stumped. They didn't give me equations. Oh, by the way, everyone, happens all the time, I get this on the test. Can you tell me why that's wrong? I just built a what? I just built a rectangle. You did too much, right? You did too much. I would be a rectangle, so I always want you to always think. Sometimes people think triangles before numbers. It's like, no. You need that. Anybody know a math way to get these equations? That's all we need. Oh, good. It's 2 points, straight lines. This is really outstanding. All we gotta do is get the equations line, like rise over run and stuff. So the y-intercept, mx plus b, the y-intercept is 0. And the rise run is rise 2, run 2. What's that slope? Y equals x. That's how I got that line. Rise over run, y equals mx plus b. This one, everyone, what's the b value? Y equals mx plus b. The b value is a 4. Do you notice, though, isn't the slope negative?
Mm-hmm.
Okay, good. Slope's going to be negative. Negative rise 2, run 2. So what would be that equation? Good. Negative x plus 4. There's his mx plus b. He says you got a negative 1x for the slope plus the y-intercept of 4. Anyone okay on that stuff? Let's check. Oh yeah, awesome. So that's what I mean. I'm just doing mx plus b. If you have to, feel free to do like, you know, y sub 2 minus y sub 1 over x sub 2, but we can always get the equation of straight lines by just taking those 2 points they gave us. So now, who's here? That's the negative x plus 4. Who's down here? X. Is that what I'm going with? Nice. Let's see how this plays out. I know from I could already set it up. Let's move on to another problem. I still think, everyone, today, it's good that you just show me that you know how to do iterated integrals. So what are you integrating this with respect to?
Y,
All right. What's the integral of x with respect to y?
X, Y.
Ooh, and you got to substitute the negative x plus 4 and then the next into the y's. So I get x times negative x plus 4. Someone told me 4 minus x. That's probably an easier way to write that. I heard that. That's easier. It looks better too. I'm going to write it that way. I totally agree. When you substitute a 4 minus, it just looks lovely. X times 4 minus x. Minus x times an x, right? Which becomes what? 4x minus x squared, or?
4 plus 2x squared.
And then carry this down. 2x squared. 2x cubed over 3. Becomes 8. Alright, what's 8 minus 16 thirds? What's 24 thirds minus 16 thirds?
8 thirds.
There it is. There's the answer. That's a good value with that difficult. Hey, every once in a while, guess what you're going to see with some of these problems? If you do every problem out of the test, like every problem, every once in a while you're going to get an integration by parts, right? Every once in a while you get an integration by parts. You remember partial fractions? I don't think you'll see many of those. But every once in a while you get, if you did this every problem out of the book,